So today's topic of discussion is we want to discuss about exception handling. Okay. Now, what is exception? What is the handling around it? So all of it we'll discuss, right? So first of all, we have to understand. Okay, let me write the agenda for today. So we will first try to understand what is an exception class. Okay. So again, there is a class named as exception in Java. What is that? We'll cover it. Okay. There are subtypes, right? I mean the childs of it. So we'll see them. Okay. What are those? Now, what do you really mean by exception? Anyhow, we're going to cover it, but we are going to see like if the exception occurs, how to handle. So handling part, so we'll see, right? How to do it. Now, when it comes to handle, right? Now, there are two ways. Either you handle it or you declare it. Okay. So we'll discuss about both of them. When it comes to handling, you would be using a concept of try, catch, finally block. Okay. When it comes to declaring, you would be using the concept of throws. Okay. We'll talk about this. We will talk about the okay. We will talk about the stack trace. What is this? We'll talk about it and how does the error or not the error exception? How does the exception gets propagated from from one class to another? Right. So exception propagation we will see, right, and how it happens and how it is. I mean, how does it work, right? On the basis of call stack, we'll talk about that part also. Okay, and under this category, right, we will see why. I mean, we can have multiple concept here, like a simple try block, a simple try with the catch block, or a try block with multiple catch blocks, C1, Cn, right? How that works. We can have try block with the catch block C1 or Cn, and then the finally block, or you could have try block with the finally block. So we'll see all of this, right? We'll see like what I really mean by all of this. But these are the five different variants which you can see. And throws we'll see about like what is the throws and how it helps in the exception propagation. Okay, there is a concept of checked and unchecked exceptions. Okay, what is that? We'll talk about that also. We'll talk about what is errors versus exceptions. These are two different things in Java at least. Okay, so we'll talk about them. Although I don't know like how best I can explain it, but let's see. Actually, I wanted to do some R&D on it, and on this part on this part, which I could not complete. But let's see. I think people here will also have some insights about it. So we'll take the input from everyone if whoever is aware about this, because I am left with some my due diligence which I did not do, so which I should do. Okay, so let's start, right? Okay, what is an exception? Or let me first show you some of the things. Uh, Let me open the project actually first of all. So
Akhil, just one question in the meanwhile.
yeah, so
Do we intend to cover debugging in IDE?
yes, I initially thought about it, and I think we can do it actually. And let's do it tomorrow. If you can remind tomorrow, we'll cover it tomorrow itself.
Well, tomorrow I'm not sure if I would show up or not. I have
Okay,
some engagement at that personal end, so I might not show
okay,
up tomorrow.
okay,
But
okay,
nonetheless, I'll try to remind you.
okay, man. No worries, no worries. Since you reminded me today, I will. I'm sure that I will remember it. But yeah, but I'll try to cover it tomorrow itself. Thank you.
Right.
That's
Thank you.
all. Mhm. Waiting for the project to finish. Okay, now we are good. Let me just simply check Git status. Git status. So okay, I did not check in yesterday's changes. Let me do it. Git add dot and then git commit minus m day 17 changes changes, and let me just push it. Git push origin day 17. Okay. I'm not sure like does everyone has the access to this repo and they are referring it if they need it. But let me just provide the link again so that if someone wants to refer this repo, right, where I'm pushing all the code, so that if anyone wants to access it, they can. Uh, so this is our repo where I'm pushing every day all our code, right? So you can see we have the code day wise. So today is day 17, so all the code resides here for day 17 now, right? So let me just share it with everyone. Uh, this is Java, and it's a public repo as of now. I intend to make it a private repo, uh, so that I will give you all of you the access. But I will see if I want to do it or not. But let it be public as of now. So I'm sharing with everyone. Let me do it on Discord. I believe I think it would be a better option. Discord. Whoever wants to refer the code, although I'm sure you are already aware about it, but just for the time being. Okay. In the meanwhile, let me. Okay, I have this opened up. So let me share this Java. Uh, okay. So I've shared it. Let me now cut the branch for today's work. Git checkout minus b day 18. Right. And on this side, let me remove everything here. Uh, delete, delete, and now we are good here. Let me create a class directly. So what I'll do is I'll try to create uh, some hierarchy of the classes, right? I mean, when I say hierarchy, it's not parent-child relationship, but just some classes. Let me create a class named as school first of all. Okay, school is my class here, and I will have my entry, my magic method inside this, which is my main method. So I've created this and let it be here. Now what I'll do is I'll create another method, another class, and I will say, let's say class, not classroom. Sorry, let's say classroom. Okay, so I'll create a class termed as classroom, and here I will have a method as public uh, uh, int uh, get uh, get get student count. Let's say okay, let's get student count, and it's a public method. Now it wants int value, so let me provide return 0. As of now, we are fine. Now let me get one more class about which would be about student. Okay, about student. So this is a class, and here I will have some parameters. Let's say public string name, and let me use the proper case, and I will add a method public void or string get name. Let's say okay. Now I did this, and let me say return, let's say okay as of now, so that errors are gone, right? So now you can see why it is complaining still. Yeah, it is not complaining now. So you can see what is the hierarchy. In the starting we have the school method, okay, which would be like the entry point, right, for our program here. What I'll do next is I will invoke the method, let's say the classroom from it, right? So for that, what I have to do is I will create the instance of the classroom cr equals to new classroom. Okay, and over there I will say cr dot get student count. Let's say okay. Now what I'll do is let me just improvise further. Uh, let me create an array. Let me create an array of students here. Student. students equals to new students, and let's say I want to have five students in it. Okay, student, right? Student. So five students of it, let's say, right? And okay, it's a student array, and okay, this is an array of students, right? As of now, okay, but it does. What should I do here? And this is the student class, right? So let me do one more thing. Let me create a public student, right? And I will accept. We have also not covered, I think, this keyword, right? Everyone, we just covered it on a high level, I believe. Or did we
Yeah,
cover? We did
no,
not
I think
cover this, right?
yeah, it was covered at high level only.
Okay, okay. Let
Not
me
sure
see
if
that.
super was also covered.
Super was covered, I know, because
Okay,
someone asked me about super, and we discussed in depth. I think Rafaelia asked us, so, so I
okay,
did cover that part. But yes, we did not cover this keyword in a depth. So maybe tomorrow I'll cover this part also. But as of now, let it be this way only. So uh, okay, so this is all done. This is string get name, and okay, fine. Let's go to the school and in the classroom, and I will add some students now. So what I'll do is new student, right, and let's provide the name as Atul. Okay, let's do this, and what we'll do is we'll say student S1 equals to Atul, student S2 equals to, let's say, Ananya. Okay, and what we are trying to return, we are trying to return this. Instead of doing this, right, what I'll do is I'll return students dot length, right? It's an int value, so this should also suffice my need. So now I have created an array of students which can hold five values, but I purposefully added only two. And this is the student class, and this is how it looks like. And I have a school where it will invoke this method, get student count, right? Now let's do one thing. What I'll do is uh, let me do one thing here. Instead of let's say this is my logic currently, right? I have written students.length here. Let me say that by mistake I will do something like this, slash by zero, right? Let's say slash by zero I'll do. Now in mathematical terms, like, what do we understand by this? If you divide a number by zero, what happens? The value is infinity, right? If you divide anything by zero, it becomes infinity. Now if in Java, right, any of your value returns infinity, let's see what happens in that case. How does our system respond? Okay, so let me run this main method. Let's run this. You see here, it has thrown some output, and it has not returned something. I mean, the program did not run successfully actually. What is happening here is, it says that exception in thread main in thread main java.lang arithmetic exception, right, was thrown, and the error which was given was that you are trying to divide a number by zero, which we were doing, right? And here it says that at classroom dot get student, right, it is telling where it has failed. We tried to run the class school there, right? So this was, so again, try to understand. JVM invoked this method, and as part of this main method logic, right, we are trying to invoke this method, get student count, right? And once so from JVM the control went to main, and from main the control went to this method, which is sitting here. And in this method, the error occurred at line number 10. So now try to read this. It says the exception occurred at classroom dot get student count. So classroom is this class, right? Get student count is this method, and you can see it shows you the line number also, line number 10, and you can see this is a line where we did something wrong and it is resulting into some exception. What is exception and all, we'll talk about it. But you can see this information, you can see. And this is not all, right? You can see this is the first line being printed because this is the place where the error is originated, right? This is the place. But it is also giving you a stack track, right? Stack trace, which is telling like the control is here currently where the error occurred, but who invoked this method also. It is telling you that also. You can see. So this thing, right, was invoked because some of the logic may be sitting inside this method, which is a school class and the main method. And here line number 6 seems to be invoking such a method. If you would go there, right? So this is school class and this is the main method, and line number 6 is this, right? So you can see, right? This stack trace, right, is giving you a lot of information here. It is telling you like what is the error first of all, what is the exception first of all, right? Which class of exception it belong to. It is giving you the even in the arithmetic exception there could be multiple reasons of exceptions. It is giving that reason that here it failed by zero. I mean, you're trying to divide by zero, so it's an exception. And it is also telling you like which line of code is the faulty one, right, where the exception occurred, right? And it is also telling you what is the path your program took to reach there, right? So all of this information, right, is very vital when you got an exception, right? I mean, when you're facing such issues where your program is not working, you can see, right? I was thinking that it will return me value 2 and I would print this. Let me print it out. So I will say count equals to this, and I wanted to print this, right? I wanted to print this, right? I wanted to do this, but now nothing has happened, right? And it has just thrown the exception. So what is happening here is that the user, because of this exception, right, the normal program flow got halted, right? And as soon as this exception thing occurred, your program did not complete it, and wherever it was able to reach by that time, it would have executed that piece of code. But after that, right, it just stopped. It just stopped, right? And you could not do anything after this. Okay. So let's get back to our drawing board first. Where is, yeah, here. Okay. So what is an exception? So in the ideal case, right, what we have school class where you have a main method, and main method here, right, is invoking something which is assigning another class, which is, let's say, classroom, right? And you have you have another method, let's say m1, whatever that method is, and here you're doing something here, right? So from here the invocation went to this, and from here, right, this like piece of line was working, and maybe it would have called something else also. And who invoked main? JVM. Our JVM invoked what? Main method. Now, right? See, the error occurred here, right? So if the error did not occur, right, what was the expected output? That the program would have successfully ran, and we would have got the output, and would have used it. But now, because of this exception, right, your program got halted. Okay, your program got halted, right? It got halted means it got stopped, right? It got stopped, and now you could not achieve what you intended to achieve. So the definition of exception is anything which halts the or which alters the program flow, right? You can see, right, you wanted to print the count, right? But because of that exception thing, what happened was the program stopped and you could not achieve your intended objective. Okay. Now, because of this exception thing, right, we now got we again, right, here we did it purposefully, right? We divided by zero. But let's say that I am accepting that input from the user, right? Let's say I am accepting that input from the user. Let's say number here, right? Num, right? Here I was making a mistake, but let's say this time, right? Why it is complaining? Because I invoke this way. So let's say I can give value here 0 also, right? You can see here now I'm not making a mistake. But here, someone who would be invoking this method, right, is making a mistake, which I cannot control, right? If let's say someone is providing that input, maybe I have not done the due diligence here, and it is failing because of the someone else, right? Whatever value they are providing, which I don't have a control on, let's say. So here, right, you can see now what will happen. Again, the same thing will happen. Zero is going in, and when zero goes there and tries to divide this number by zero, it will result into a failure, and your program will not run, right? So to avoid this, right, and so to avoid the exception which is halting your program, right, there is a need that you can handle such cases, okay, where let's say that that situation occurred. Let's say someone did provided me a zero, and it is stopping my program, but my goal is that it should not stop, rather it should do something else, right, and it should try to come out of that situation and then continue my normal flow so that I can achieve what I wanted to achieve as part of my program. So this process is called what? It is called as exception handling. Okay, you handle that exception, which can result into a failure, right, for you. So you want to handle that thing. So let me say here, exception handling. Exception handling is a way to resume the normal flow of execution. Okay, resume the normal flow of execution. And here the exception was to stop the normal flow of execution. Okay, but if you have provided the right handling there, things will start resume, right, it will not stop and you can continue running your program. Now how to do it and what all it is about, right? So we'll talk about it then, right? One thing which you should know in Java, right, I keep saying this, everything in Java except primitive data types, right, everything else in Java is what? Objects, nothing else. Objects, classes, whatever you want to say, those are those things only, right, except the primitive data types. uh, Other than that, everything else is in Java is what? Objects only. So is the case with exception also. In Java, there's a proper hierarchy which they have created in by the Java developers, right? And the hierarchy looks like this. You have who is the root of who is the super parent of everything in Java? Can someone tell me? We
Object
discussed
class.
it. Sorry, which class?
Object.
Yes, object class, right? So object class is something from which everything starts in Java. Okay. So object class is that class. We discussed this, right, everyone? Now within the object class, right, there is one parent child. There's a child class here with the name as throwable. Okay, throwable. Now within throwable, there are two childs. One child is error, and the other child is exception. The exception which we are talking about. Okay, these are exceptions. Now within error, right? Okay, just a second. Did I draw it very correctly? Just a second. Where is my note? Yes, I did draw it correctly, but there. Okay, within the exception, right? There are two further categories. One is runtime exceptions. Okay, one is runtime exception, and the other is the other types of exceptions. Okay. Now within errors also, right? You could have multiple hierarchy, multiple classes, and all that. It could exist, right? Okay, so this is like how the flow, I mean, this is how the structure of the exception classes and the other classes are there in Java, right, which are already in place. Okay, you just need to know about it, right, that how it is, how things are linked. We are talking about exception here, right? We are not talking about errors, we are not talking about variable, we are not talking about object, but we need to understand like what is the complete hierarchy looks like. So everything starts from object, there is a child of it which is throwable, and throwable has two other childs which are error and exception. Within exception, you have one child which is called runtime exception, and there are other types of exception which exist there. Now, there is a very common question in interviews, right, which people ask: what is the difference between checked exception and unchecked exceptions? Checked and unchecked exceptions. Okay. People ask this, right? There are there are two questions which they ask. First, the difference between them, right? The difference between them, and they also ask like what belongs to which category, right? So first, let's understand what is a checked exception and what is an unchecked exception. Anything, right, which may exist here, okay, on this side, whatever may exist, right, here, this is called as checked exceptions. We'll talk about it, right? What is that? What is this all about? But anything, right, which may fall like here, like maybe there are some classes here, some classes here, some classes here, right? Whatever that hierarchy would be, everything, right, just leaving out the runtime exception, inside exception, right? Everything else in exception is called as checked exception. Okay. What is unchecked exceptions? Everything inside errors plus this runtime exception, right, is termed as unchecked exceptions. Okay. Now, what is the difference here? The difference here is you cannot do anything for the unchecked exceptions. If they occur, they occur. You cannot you cannot do anything about it. Okay. But with the checked exception, as the name says, checked, right? You can make a check on it, and then you can prevent it from stopping your program. Okay, you can do that. So that's why the names are this: unchecked and checked. You, if your program may have any of these exceptions, right, because of the logic which you may have written, and you presume it like, okay, this could occur, right? Then you may try to put some handling around it, right? But those handling can only happen for what kind of exceptions? For only these kind of exceptions. Okay, you cannot do anything for the unchecked exception. Is this point clear? And when I say about unchecked exceptions, you can see what is falling inside this. Everything about errors falls inside this, right? Plus the runtime exceptions from the exception class falls inside this. Let us see. Let me show you the exception class first. Exception. Let's go inside this. You can see it's a class, right? Exception, and it is extending throwable class, right? Which I showed you. And if you would see the throwable class, okay, it implements, right? And since it is not extending anything, so by default, which class it extends? Object class, right? So let's close this. We don't want to go there. What I wanted to show you is this exception class. Now you will not be able to see what all childs of exception class here, but let me show you on the Java doc. Exception class, uh, Java doc, Oracle, SE8. Okay, okay, let's open SE8 only. We are in 21, right? Let us see if this works. Okay, 3D 21 documentation, which is fine, and API documentation. Okay, fine, and let's search here exception. You can see, right, exception here. Let us just try. I think this is the one which you're talking about, java.lang.exception. And if you would see, right, this exception class has so many childs. You can see absent information exception, agent initial. You can see, right, direct known subclasses. Okay, if there are grandchilds of this exception, right, I think they will not be listed down here. So if you can go inside the individual classes and try to see if there are some more subclasses inside them. Okay, but I'm not telling you that you have to learn all of this. No, I'm just trying to show you that how the hierarchy looks like. Okay, so if you would see about the exception, I think one of or few of the exceptions which you would have already gone through in your career, maybe array index bound of exception, right, where you try to access something outside the size of the array. So that type of exception you may have seen. Let's say null pointer exception, very common one, right, which people keep on seeing. So that is also an exception. And there are similarly more exceptions, right? Let me try to see if I can find some of them from here.
Class not
uh,
found, file not found.
right, file not found, IO exceptions and all that, right? So all those exceptions are here only, right? Although although I'm not sure like what belongs to runtime exceptions, because since we don't handle them, so we'll see that also. But I am hoping that everything I've said belongs to these checked exception category only. Okay. So again, but let me see if I can find something which is. Let me do it for me, Anna. What was the name? Let me duplicate this and let's find the null pointer exception. Let's see where that fits in. Null pointer exception, right? Here it is. Let us see which is who is the parent of it. So null pointer exception is the parent for it. Oh, it's a runtime exception. Oh, great. It's a runtime exception. It's a runtime exception. So we don't handle it here. Okay, great. We got to know something. So it's not a checked exception. Okay. What is the other exception? Array index bound of exception. Array index out of bound exception, right? Let's see where it is a part of. It is again runtime exception. Ah, it's strange. Okay, really? Okay. What is okay? Let me see. Am I telling you the right thing or wrong thing? Just a second. Checked exception. I told you I did not do my due diligence very correctly. Let me see. Checked exceptions. What is unchecked exceptions? Okay, let's check this link. Okay, you can see here it shows you some things here, right? Okay. In Java, exception is an unwanted or unexpected event, right? Which occurs during the execution of program at runtime that disrupts the normal flow of the program, which we discussed. In Java, there are two types of exceptions: checked exceptions and unchecked exceptions. Now, this is the hierarchy which we learned: object throwable exceptions and errors, right? And there is a category of you can see, right? You can see here, right? Runtime exceptions is a part of unchecked only. So that explanation is correct, right? So runtime is a part of unchecked. Now we have to understand what is the difference between checked and unchecked. First of all, these are the exceptions that are checked at compile time. If some code within a method throws a checked exception, then the method must either. Okay, so this is something which is checked at compile time. Okay, if some code within the method throws a checked exception, then the method must either handle the exception or it must specify the exception using the throws keyword. Okay, so in a checked exception also there are two types of fully checked and partially checked. A fully checked exception is a checked exception where all its child classes are also checked. Okay, a partial checked exception is a checked exception where some of its childs are unchecked. Okay, like an exception. Okay, for example, consider the following program that opens the file at this and prints the first three lines. The program does not compile because the function main uses file reader and file reader throws a checked exception, file not found exception. It also uses read line and close method, and these methods also throw checked exceptions. Okay, so it will not run and you will have to handle them or fix them. To fix the problem, we either need to specify a list of exceptions using throws or we need to try catch. Okay, fine. They would have used a try catch block here. Did they do it? They did not do it. We need either to specify a list of exceptions using throws or we need to use a try catch block. We have used throws in the they have used the throws keyword. Here is the throws statement I was seeing where it is went. So there is a throws keyword. So they did not handle it. They just said that okay, it's not my responsibility. Someone else needs to fix it. Okay, let's talk about this unchecked. These are the exceptions that are not checked at compile time. In C++, all exceptions are unchecked. Okay, so it is not forced by the compilers to either handle or this. Okay, it is up to the programmers to be civilized. It is up to the programmers to be civilized, right? And specify or catch the exceptions. That's a good word, civilized. In Java, exceptions under error and runtime exceptions, right? You can see, right? It says in Java, exceptions under error and runtime exceptions classes are called unchecked exceptions. Everything else under throwable is checked, which we discussed. Consider the following Java program. It compiles fine, but it throws arithmetic exception when run. Right? The compiler allows it to compile because arithmetic exception is an unchecked exception. Okay, in short, unchecked exception or runtime exception that are not part of the code or declared as throws keyword. The unchecked are runtime exceptions that are not required to be caught declared as throws keyword. These exceptions are usually caused by programming errors. Are runtime exceptions that are not required to be caught or declared in a such as attempting to access an index protocol and dividing by zero. Unchecked exceptions include all subclasses of runtime classes as well as the error class and subclass. Okay, fine. Okay. is thrown when you attempt to divide by zero of this. Okay, okay, okay. Little correction from my side then. Okay, what we were discussed. This is fine, right? What I just said you is fine. This is unchecked exception and this is checked exception, right? But what is the difference between the checked and unchecked, right? There I was wrong in one part. Now, when I say checked, right? This checked versus unchecked. First of all, again, I don't even I myself is not aware like what all falls under unchecked and checked, right? Which we can get to know once we see those classes, right, and get to learn from there. I mean, we can, but we can make out, right? If it is belonging to error class, then it is definitely an unchecked. Okay, so anything inside the error class, right? Any class or subclass inside this, right? All belongs to the unchecked category. Plus any class, right, inside runtime or runtime exception itself, right, are part of unchecked exceptions. Okay, and runtime exceptions, right? Everything else, right, everything else, right, would be, so everything else would be a checked exception. Everything else is checked exceptions. So first of all, this is very clear, right, from this diagram also, right? What is checked and what is unchecked. Now, what do you really mean by checked here, right? When it says checked, right, it is saying that if your program, right, has a logic which can result into one checked exception, right, then at compile time itself, at compile time itself, it will detect it. It will detect it. Okay, it will detect it, and it will force you. It will force you to either handle it. Okay, either handle it or throw it, right? When I say handle, you would be using what? You would be using a try catch block kind of a situation. But if you do not handle it, right, and you say that okay, it is not my responsibility to handle this, I will throw it to the person, I will throw it to someone who would have invoked my method, right? Then it will become the problem of that method, not mine. Okay, so this is throwing, right? So you are skipping your responsibility. Here you're taking the control and saying that okay, this is my area and this is something which I need to provide a handling on. So you will provide it. Otherwise, you can also throw it. Okay. So these are the two ways. But here the point is at compile time itself, your code will detect that you are required to handle such exceptions if you have a logic like this. Okay. In case of unchecked, right? Your compile time they are not detected. Okay, at compile time they are not detected. They are not detected, and now the only place which is left would be when you run your program. When you run your program, you run your program, right? Only then you can you can get to know about them. Okay, you can get to know about them. Okay, you can get to know about them. Now here also, right? Here also, what you can do in this case is you can provide your exception handling. You can provide it. It's not that you cannot provide. You can provide exception handling, right? But it is like that maybe after getting that error you will add that logic of handling, right? But here, right, it will not even allow you to run the program, and here you are safer, you're safe here, right? Because before even running your program, your Java compiler, right, or the JVM here, right, sorry, not the JVM compiler here will detect everything, right, and it will tell you okay that you missed this here and you have such a logic, please uh, handle it or throw it. Okay, so here your program will not run if you don't do this, but here the program will run and you can get the error and then you can provide the exception handling. So exception handling, I believe, is you can do in both the places, here also and here also. But here you can do it before running, and here you will do after running it. So in our case, right, when we were discussing here, as we saw this part, which is this classroom here, right, this part here, dividing by zero, right? Now dividing by zero resulting into arithmetic exception. So if you would check here, arithmetic exception, right, it's a part of runtime exception, right? And you can see I have not handled it and my program is still running. At least it is running, right? It is running here. It is still running. It is not allowing me to stop. But if you do another operation. Let me do it. Let me say operation like this. I think file operations are checked exceptions. Let me check that also. Let me write here uh, IO exceptions. IO exceptions, right? If I check this, this is okay. This is again okay. This is another kind of exception part, but inside exception, right? Okay, this is fine, right? Okay, yeah, right. So this is a checked exception, right? So what you can do is, if I do a logic here, let's say I write a logic here. Let's say I want to read a file. What I can do is I will say file f1 equals to new file, and let me say I'll provide a path here. Okay, let's say I'll okay. First of all, I cannot write it here because just a second. Import class. Okay. Uh, will it work? Okay. Hmm. Okay, just a second. Let me check one more thing. New URL. If I give a URL as https podtest.in, okay, and I will, what is the written type it throws? Cannot resolve, let's say import class. Yes, java.net. It imported the class, and what is the written type of it? Written type is nothing. It I have to provide the URL only. So let's say URL, let's say my website equals to this, right? Now you can see, right? It looks like a normal thing, right? Here, right? You URL is again a class in Java, right? You can see here, right? This is what it's a URL. It's a class or what? It's not a class. Creates a URL object from the string representation. Okay, okay. It's altogether a different thing. But you can see here, right? What is happening here is that when I'm trying to write this line, it is complaining. Although the syntax looks fine, but it is complaining. It is saying that there is an unhandled exception, right? Which is this malformed URL exception. Let us let us first, and it is saying that you have to add this exception. So you can see, right, at the compile time, I have not run my code, right, but here compiler was able to detect, saying that okay, that I feel like that there could be an exception if you use such thing here, right? And because I know this about this, so you will have to either handle it or throw it, right? So what I'll do is let me show you one of the way. Let's say that add exception to method signature. If I do this and let's check this exception here, you can see, right, it is throwing. And let's check this method here. You can see malformed URL exception is a subclass of IO exception. And what was IO exception? IO exception was the child of exception class. So let me just try to make things more clear. I'm sure it is not getting clear. Okay, on this part. So see here, right? We had this object class. Within object class, we have throwable class. Inside throwable class, we have exception class. And inside exception class, I told you one of the class here within the exception is runtime exception. Runtime exception. Okay. And we just saw like there are multiple runtime exceptions which are like array index out of bound and all that. So these are all runtime exceptions. But there are other exceptions also. Like we just saw IO exception, right? IO exception. And within IO exception, we have one more exception which is a malformed exception, right? Malformed exception, right? And in case of throwable, right, there is another class, the child, the sibling of exception, which is error class, right? Which we are not even concerned about. Okay, we don't know like what all methods or classes it may have. We are not even concerned about them. What we are concerned about is first of all majorly about this, which is the checked exceptions here, checked exceptions, right? And this whole category, right, of this is what unchecked exceptions. So if you have written a logic in your program, right, where that logic can result into an exception which is a part of this kind of hierarchy, right, then in that case your compiler will throw error. Compiler will throw error. Okay, and that is exactly what is happening in our case when you used new URL. Okay, new URL here. Now the way it is implemented by the Java developers, they have written in a way that maybe like whatever value you provided, right, Java does not know, right, Java does not know what kind of, whether that URL is correct or not, right, it's a string value. It's a string value which you're providing here. See this, it's a string value, right? Let me show you this. It's a string value, right? You can provide like a good URL like this, or you could just, let's say, just say blah blah blah, right? It's not a valid URL, right? And maybe after this logic, you're trying to do something based on this URL. Let's say open that URL or fetch some data from the URL, right? All of that operation you want to do. But your code here, right, does not know what kind of input you may provide. So what is done here is like by the Java developers here, they have made this as a, they have, whoever implemented this URL thing, right? If you would check this, right, see here, url.java, they are throwing this malformed exception. Okay, you just watch this signature, right, that it is throwing that method, it is throwing that exception. What is throwing and what is handling, I'm coming to that part. Okay, but just remember this. Okay, as of now, just remember this. Now let's try to do things. Okay, let's try to do things instead of doing all of this. Let's try to do this. Let's try to resolve these questions first. So we have what we have: school. This is the school class, which looks like this. uh, okay, and this is the classroom here where the exception was occurring. Why it is saying, okay, it is throwing a, right? Okay, let me remove this. Okay, so first of all, just remember that there are two types of exception: checked and unchecked. And in case of checked, the compiler will complain, and this is what it is complaining as of now. It will not allow me to run my program until I do something about it. So what can I really do here, right? So you can see it is still complaining. I have removed all the solution I have applied here, right? And as of now, it is red mark. And if I try to run this, right, if I try to run this, you can see it will throw me an exception. I mean, the compiler will complain. If I try to run, na, it will not even allow me to run. It will say that, okay, that you have some issues. So at the compiler time, at the compilation itself, it is failing, right? It is saying that unreported exception must be caught or declared to be thrown. Okay, so what it is saying here, let's talk about this now. Okay, now you have two options in Java, right? If you want to overcome such exception thing, right, if you want to overcome the exception part, there are two only possibilities in Java which you can do. Either you can be a warrior and try to and try to take it on head, right? I mean, you can try to solve it, or you can say that, okay, this is something which out this is which is something which is out of my capacity, so I will not handle it, and I will let someone else handle it. Okay, so there are only two ways: either you will face it, or you will say, no, I will not face it, maybe someone else will face it, but I will let that person know that something can come your way. Okay, so these are the two only possibilities: either you will face, or you will throw, or you will ask someone else to look at it. Okay, so what does it mean in Java, right? The first thing here means handling. Okay, the handling part: any piece of code which you feel can throw an exception, it is not that they will definitely throw an exception, but they may or may not throw an exception, right? In this case here, right, your Java does not know that this URL is correct or incorrect. This is us, we know as of now, right? But let's say there are cases where you can also not know, right? But to be safe, we want to handle this, right? So what we'll say is, let's say https and all that, right? Test.in. You can see I'm providing a valid and it's still complaining. Why? Because it's a checked exception. So in this case, right, what you have to do is, there are only two possibilities. Either whatever piece of code you think can throw an exception, you will place them under what? Try block. And how to create a try block? So let's say this piece of line, right? Line number 18 was something which could result into an exception. So I have first of all made them into a guarded region. Okay. So try block is like my safe place. So any piece of code I place inside this, right? And if they throw an exception, right, then I can do something about that exception. Okay, you can understand that way. So if something bad happens inside the try block, then Java will provide me with some tools which I can use to counter that effect. Okay, so try block is something like that. So any piece of code which you think can throw an exception, you should keep it in the under the try block. Okay, okay. Let's say the exception occurred. Let's say the exception occurred at this line. You can see, right, the exception will occur. Okay, now how to handle them? To handle them, the concept is that you will use a statement, a keyword here with the name as catch. Okay, and here, right, you will have a body of it. Okay, like this. Okay, inside this here, right, inside this syntax, right, what you have to tell is what kind of exception you expect your code to throw, right? So over here, right, if you would hover over it, what kind of exception it can throw? You can see it says unhandled exception java.net malformed URL exception. Okay, so it is saying that your this piece of line can throw a malformed URL exception, right? That is the complete thing. Yeah, malformed URL exception. So it can throw that exception. So let's say, so what we are saying is, as of now, it is one line. Let's say I have another line which would be doing something like this: a divide by 0, or let's say uh, int c equals to 5 divided by 0. So here it will throw an arithmetic exception, but because arithmetic exception is what, a runtime exception, so you can the compiler will not complain, but you know that this can throw and some error, right? So again, if you want this to be, if this situation occurs, right, you still need to handle it, right? Otherwise your program will stop. Now you can see, right, you have two line of codes which can result in different errors, right? So this exception can result into malform URL exception. Okay, and this piece of line can result into another type of exception, which is arithmetic exception, right? And you can see here the compiler is not complaining, because this is something which is beyond the range of compiler cannot know here, right? They cannot make a judgment here. So that's why they are told that they are considered as runtime exceptions, because compiler cannot have a look at it, right? Now what is happening here in the catch block, right? You have to say, you need to tell what kind of exception you're trying to catch here. Okay, let's say this piece of block, right? Let's say some error occurred at this line. So what kind of exception will be thrown? A malformed exception. So what you can do is you can have a catch block here, which will be specifically for catching a malformed exception. Okay, so you can write it here, malformed URL exception, right? And let me give an alias name as E1. Okay, as soon as you do this, you can see the error below the URL is gone. That the red sign is gone, because as per the rules of Java, what you've done is, you first of all you have to understand it's a checked exceptions. So you now are forced to handle it, right? And if you don't handle it, your program will not run, anyhow will not run, right? So what you have to do is, you can either use try catch, or we will see what other approach we can take. But if you use try catch, right, and here, right, you have marked the name of the exception which can be thrown from this. So now Java is now the compiler is happy. It knows that even if something bad happens about the URL, then let's say something bad happens with the URL, so it knows that the control from this line would be moved from here directly to a catch block which matches to that exception, which is here, right? Which is here. And here, right, you can write your counter steps, right? Let's say here you can, whatever steps you feel, right? Let's say here you will provide another URL, okay, or something around it, right? So you can use it. But here let me just simply say, I handled malform exception. Okay, I handle malformed exception here, right? Let's say. Or okay, what about this arithmetic exception? If the error occurs on the arithmetic exception, will that let's say it occurs, right? Will it go inside this catch block? It will not go. It will not go because I'll come to that part why it will not go, right? But here you have to understand that for this kind of exception, right, there has to be a matching catch block. Okay, there has to be a matching catch block. So what you can do is, let me create another catch block, and I will here this time say arithmetic exception, right? You can see here arithmetic exception. Just write it here. Let me provide E2 the alias name, and I can do it here, right? And now if the exception occurs at this line, right, which is an arithmetic exception, because that is the only exception which can occur at that place. So if that occurs, right, it will first see the syntax of this catch block. It will find, okay, this catch block is meant for only handling this type of exception. An arithmetic exception is not this exception, so it will not go inside this. And then it will move to the next exception. And if it finds the matching exception for it, it will go inside this and run that piece of code. So here, let me write here, I handled uh, arithmetic exception, right? Now inside arithmetic exception also, right, there are multiple exceptions there. Let me show you. I believe there must be arithmetic exception. Uh, okay, there are none actually. Okay, great. So it does not have. Okay, so everything inside this is like different types of all these arithmetic exceptions can be handled by this thing only. Okay, but I think inside you can see, right, thrown when an exceptional arithmetic condition is occurred. So all for all the arithmetic operations, if something bad happens, right, then it is the one which will handle it. For example, an integer divided by 0 throws an instance of this class. So maybe constructed by the virtual machine as okay. Okay, right? So I hope you're getting the point, right? Now, if I go back here, right, what I'm saying is there are two options. One is handle. When you say handle, right, when you would decide, okay, I need to face it. So in that way, in that case, right, what you'll do is you will write a try block, open the braces, and whatever logic you think can result into an exception, you will place inside the try block here, right? Whatever you want, you can have it here. Okay, you can have it here. So it is like a guarded region, right, where you are safe. If something occurs here, right, then Java, if something occurs here inside the try block, right, then you can do something about it. And how to do something about it? To handle it, right, if the error occurred, what you have to do is you need to have a catch block. And inside the catch block, you need to mention the name of the exception, which this catch block needs to handle. So it can have, let's say, malformed exception, as we just discussed, right? Malformed exception. So if an error of this type, if an exception of this type occurred inside your this logic here, right, then the control will move to this here, right, in this catch block. But let's say something else occurred, like arithmetic exception, right? So in that case, it will not go inside this, and it will go inside this block, and whatever we would have written here, right, would get executed. Okay, and this is called as handling. You are handling the exception. The error occurred, the exception occurred, and you're handling it. Okay, now as part of this exercise, you also learned that you can have multiple catch blocks. You can have multiple catch blocks catch blocks inside your logic, right? You can have it. So for a single, so for one try thing, right, you can have multiple catch blocks. You can see the try block is only one, right? And you can have multiple catch blocks in it. Why is that? Because you may have 10 lines of code here, right? And maybe some of the lines can result into some kind of other exceptions. And to handle those kind of exceptions, you need some specific, logic, right? So you can bifurcate here, right? If a malformed exception occurred, okay, run this piece of code. If an arithmetic exception occurs, okay, run this piece of code, right? And mind you, if any of the catch block ran, right, the rest of the catch blocks would be skipped. Okay. Okay. Now, coming to a very important point, we discussed about this exception thing, right? Where exception is a class, right? Exception is a class, and it follows the hierarchy of a parent-child thing, right? Where exception is like the parent of all the exceptions. And if we specifically talk about this thing, right, runtime and all that, right? So these are, if you would see who's the parent, exception is the parent of IO exception also, and even for malformed exception, right? Maybe a grandparent, but it is above in the hierarchy, right? Even for runtime exception, exception is the class. Now we learned, right, that you could write your code like this. We talked about this. If you're trying to create the instance of a class, if you try to create the instance of a class, you can do this. You can say parent class name n1 equals to new child class name, right? We can do this if we are trying to create the instance of the class, right? Similarly, what you can do is, if an exception of IO type, right, IO exception occurred, right, which is a child of exception class, which is a child of exception class, right, which is a child of exception class, or a runtime exception occurred. Let's say arithmetic exception occurred, right? Arithmetic exception occurred, which is a child of runtime, but runtime is anyhow a child of exception, right? Similarly, here, right, IO exception, malformed exception, right? Let's say I have a logic somewhere in over here which can result into these four kind of exceptions. Let's say now what I can do here is I can also do one thing. Now let's say, first of all, as per the understanding which we had, how many catch blocks I would require to handle? Just one. If my piece of code returns, let's say, have a logic which can generate any of these exceptions, how many catch blocks I should ideally have?
Um, so
What?
it should
Hmm.
it should have the number of exceptions it might face,
Right.
right?
So in our case, I am saying it can generate four types of different exceptions. So how many
Hmm.
catch blocks I should ideally have? Four catch blocks,
Four.
right? If an
Four.
arithmetic if an arithmetic expression occurs, then that piece of catch block can run. Or if a runtime exception occurred, let's say some other exception occurred in the runtime, then runtime exception will occur, right? That block can then that catch block can be executed, right? Now,
Yeah.
but in a nutshell, you if you would see all these four, right, are a child of exception only, right? Right?
Yeah.
And if we talk about runtime, right, in the runtime, arithmetic expression is one child, other child is like array, index, out of bound of exception, right? So this is also a child of whom? Runtime exception, right? So in Java, what you can also do is, instead of writing the specific exception names, right? Right? What you could also do is, you could simply write the name of a parent. Okay. Let's say, I will write a logic like this. I will say, uh, I have a code block like this where I will say int c equals to 5 divided by 0, and it also has a code of, let's say, I have an array of int which is of uh, a, let's say, and new int, and I will add here 1, 2, 3. Okay, this is an array, and I have written a logic here to grab the index 4 of this array. So you can understand, and this is my try block. This will throw what? Ananya, what kind of exception this will throw? This line,
Arithmetic exception.
arithmetic exception, right?
Yes.
Arithmetic exception. Atif, what kind of exception this will throw?
Array index out of bound.
Right? Array index out of bound. Let us first see again. If you would see, right, arithmetic exception, right? Arithmetic exception is a child of whom? A runtime exception, right, everyone?
Yeah.
Right? So let me go to the board again. So if I draw the hierarchy, right, we had exception, and we had a runtime exception, and within runtime exception we saw we have arithmetic exception. arithmetic exception. Similarly, the other child which the runtime has is array index out of bound. Let us see that also. Array index out of bound exception, right? So if you would see, this is also array index out of bound exception, right? So this is the one, right? Index out of bound. Okay, array index out of bound is a child of index out of bound, and index out of bound is a child of runtime, right? So the hierarchy looks like this. So index out of bound, there is a class like this, and inside this there is a child called array index out of bound, right? So this arithmetic exception is pointing to this, and this array index bound of is pointing to this, right? But see here, right? If you would check who, like, if you check the parent hierarchy, right? What is the common? Who is the parent? Who is the common parent for them? The most closest common parent is whom? Runtime exception, right? If you would see for arithmetic, this is the most common. Most nearby parent, and similarly, the array index bound of one, right? The runtime, right? It is the one. Okay, it is a grandparent, but this is like in the above in the tree hierarchy, right? This is there. Now what I can do here is I can use either this approach. I can use two catch blocks, and I will use one catch block for arithmetic exception, okay, E1, and I will write my code here. Or I can do catch block, and I can write here array index out of bound exception, right? As this is what we have discussed till now. You will have to have catch blocks per exception type, right? But what you can also do is, instead of having specific things, you can have a single catch block which can catch both types of exceptions in a single block. How will you do it? You will have to find a common parent between them. So who is the common parent here between this and this? This, right? Runtime exception. So if you write runtime exception here, E, right here, and you write your code here, right? Now, if your code, now what's here? You have only one try block and you have only one catch block instead of two. Now, runtime exception here, right? If an arithmetic exception occurs, right? This is belonging here, and then it will see, okay, it's an arithmetic exception, but you have a catch block which which handles what? Runtime exception. But since arithmetic is a child of this piece of code will still run. Okay, so it will go inside this and it will try to run whatever logic you would have write. In the second case, let's say array index found of out of bound exception will occur. First of all, it will not find the specific one, but it will try to see, do I have a parent of it? So we do have a catch block which is a parent of it, right? Which is runtime exception here. So this time also your piece of code will run. Okay, so now if you use a common parent, right, in the catch block, then there is no need to use these specific things, right? Okay, is everyone getting this point or no?
Yes, okay.
We're getting this, right? In this case, right, if you would see, this is malformed exception, which is like a checked exception, and this is a arithmetic exception, which we saw here, right? Arithmetic exception is this. So if I take my case only, runtime exception, and this was the IO exception, right? IO exception, and within IO exception, I had malformed exception. Okay. Now, in my logic over there, my piece of logic is either resulting into this or this, right? So if I have to now here, right, you can see I have written two catch blocks here, malformed URL exception and arithmetic exception, right? Now I don't want to write two catch blocks. I only want to write one catch block where I will provide the required logic and it will take care of it. So what should I do? I should find a common parent. Who is the common parent? See here, arithmetic exception, you can see runtime exception, right, is one of the parent. But is it a parent of malformed exception also? No. Malformed exception, the parent is IO exception, right? And it is not anywhere in the hierarchy tree also. It is like a sibling, right? So it's not a parent for him, right? So it's like a sibling of IO exception, right? So this malformed exception is not coming from this hierarchy here. So that's why there is no commonality, at least at this point. But if you move a step back, if you check at the exception, right, over here, now if you would look at it, you would find that this exception class is something which is a common point between these two classes, right? Because arithmetic also is derived from exception, and malformed is also derived from exception. So what I can do is, instead of writing these two things, I can, let me comment this out first of all. I can comment this out, and I can do what? I can simply write one catch block which will be handling what? Exception only. And you can see your URL thing will not complain. You can see here, right? It is not complaining. Okay, and I can write and I can write my logic whatever I want. Right, everyone? So we're getting this point, right? So there are two ways, right? What you can, I mean, in the handling part itself, what you can do is you can have specific catch blocks which will be catching specific kind of exceptions, or you could have a common parent of all the exceptions, right? And maybe have it in a single catch block or multiple catch blocks again. But which is the better approach? Should you use a common parent which can handle everything inside this, or you can have specific catch blocks, right, which are meant for specific exception types? Which is the better approach?
Specific is better. Right?
Okay, who else thinks specific is better? Kusuma?
Common is better. I mean, having a parent exception is better than having the specified
Specific
ones.
is better.
Yeah, better to have a common parent instead of writing so many
Okay.
catch blocks. We might
Okay.
miss here and there some of the
Okay.
exceptions to handle. So that's
Okay.
why better to have exception class.
Okay, so Dagar, what you were saying, which is better?
Specific is better. Okay.
Specific is better, you're saying, right?
Yes, yes.
Okay. Ananya, you were also saying something.
I would prefer a common one because at times I may not know what kind of exceptions may arise. So
Okay.
yeah, so I would prefer a common one. Probably.
Okay. Okay. And Fizula, for you?
I mean, I guess the common exceptions are better, yes.
Okay. And Rafaelia, for you? Okay, my chat box is not working today. I don't know why, but no worries. Okay,
She
so
said
what I'll say
common.
is common only. Okay, she said common. Okay, fine. Okay, let me answer this, right? Specific ones are better. Okay, why is that? See, if you have to think about it, right? Think about it, right? Let's say uh, you have a very complex logic in the try block, and that try block can have, let's say, 5 or 6 different types of exceptions, right? Let's say first of all, you should not be in a habit to place everything inside the try block, right? You should not do it. You should only try to put something in a try block which you think can result into some kind of exceptions. Only that piece of code should reside inside the try block. It should not be that you create a method and everything inside this you create a try block for them to keep, right? And then you start adding catch blocks. No, that is not the idea behind having a try catch. A try catch block should only go there where you think, or the compiler thinks, that something can go wrong. Only in those places you use the try catch blocks. Okay, first of all, this should be very clear. We do not have to place all our code inside try catch block, right? Second thing, when it comes, let's say that we have a logic which can result into multiple types of exceptions. Let's say one of the exception can be on the URL, second of type of exception could be on file handling, third type of exception is on, let's say, this arithmetic exception, and maybe uh, some other exceptions, right? There could be n number of exceptions there. Now try to see, if you have to provide a counter, let's say the malformed URL came, right, and you were not, the URL which was provided was not good, and it resulted into that exception. What is your corrective steps which you will take? The corrective steps would be for you is that you would try to maybe provide a correct one, a correct URL or build a new URL, right? Based on the logic you would have defined, right? Similarly, if you're working with an arithmetic exception, let's say that you will first figure out what kind of exception it is, and then based on it, you will try to make some relevant changes there. Okay, so try to understand, right? You are trying to provide new responsibilities, right, which are required for that specific things only, right? Why to club all of this into a catch block, right? Where the okay, if you bring everything into a single catch block, right? And let's say the exception which was occurring, right, was about malformed URL, but you also added the logic of arithmetic exception and the other thing in that same catch block, right? Now what will happen because of this? You are unnecessary trying to run the piece of code which you do not want to run, because that kind of exception has not occurred. What kind of exception has occurred? Only malform. So what kind of solution you should provide? Your solution should be around malformed URL only, right? Why you would provide a solution around arithmetic exception there? No, because you do not require to handle them as of now, right? So try to understand from that perspective that according to the problem, you have to provide the solution. You do not have to provide an extra solution. Okay. So keeping that concept in mind, what is better is keep different catch blocks, right, for your different kind of exceptions which your code can generate. Okay, and handle that piece of and write the logic, right, which can meet that needs. Okay, that is the part. But there is a rule in Java where it's not like it you can start writing in any order all of this. Okay, you should not do that, that you start from any order. Okay, you found it, okay, there are 4 different exceptions, and let me use it, and let me just start adding it. Let me show you. Let's say what I mean to say is, see this, uh, let's see it here, right? Let me remove this. So we have this catch block, and this is catch block. You can see my code is currently complaining. My code is currently complaining. Why it is complaining? Let's first understand that part also. If you see this, right? Here, 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 yes. Now, if you would see this, right? My piece of code here, right, can still result into malformed, and it can also result into arithmetic exception. And these are the catch blocks which I mentioned. But this time, if I remove this line of code, let's say I remove this, you can see the errors are gone. It is not complaining. But if I add that back, it starts complaining. What is going on here? Here, the problem is that we are not fulfilling one rule of Java, which is around exceptions. The rule is that the hierarchy or the sequence of your catch blocks, right, have to be in a certain order. Which order that we are talking about? The order is the order of the parent-child relationship. What it is saying is that let's say, let's look at this code again. What kind of exception it is throwing? Malformed and runtime, right? If you would look at both the exceptions, both are part of exception. This exception, right? This part, both are part of this exception class, right? Even if I don't write it here, right? I told you, right? Even if I don't write it here, if any of these exception occurred, they will be handled here itself, right? We are on this point, right, everyone? Kusuma,
Yes.
we understand
Yes.
this point, right? That if I write only this piece of code, right? So even if I write only this piece of code, right, and if an error occurs, right, where it will be handled? Inside this catch block, right? Right, everyone? But let's say, okay, let me first place that back, right? I placed it back, and let me comment this out. Just a second. And let's see this. If I put my this thing here, right? Let's say I put my catch, this arithmetic exception, right? Now, if you would see this, right? In this logic, right, it is still throwing 2 types of exceptions: malformed and arithmetic exception. It can throw that. But what am I handling? I'm only handling arithmetic now, right? So if an error, if an exception of this type occurred, this can be handled. This can be handled here, right? But if an exception of this type occurred, it will not be handled here. We are on this part also, right, everyone? Right? If an malformed URL exception occurred, it cannot be handled on this based on this catch block, because it is only capable of handling what kind of exception? Arithmetic exception, right? And if I place catch block of this type, which is malformed, what kind of exception can be handled here? Only the malformed exceptions, not the arithmetic one. Although it will not complain because it's a unchecked exceptions, and compiler will not complain about it. But at runtime, it will fail, right? Now, what I'm trying to say here is that the point is, if you write this piece of code, let me write in different ways. Let me copy this. Let me write it here again, and let me write it one more time this way, right? In the first way, right? If I use this piece of code, Control C, right? If I write malformed exception and it catch block. Now look at this. Look at the three variants, right? The first one, okay, the first one, the second variant, and the third variant. Now tell me, if an exception of this type, malformed and run an arithmetic exception occurred, will this catch block will be able to handle it or not? Yes or no?
Yes.
It can, right? Let me write yes, because exception is a parent of both the classes. So even if an exception of any of these types occurs, the catch block is saying exception, right? So both of them can fall under this category, and we would be safe, right? Let's say in the second case, if this time a malformed exception occurred, then it will be handled here, right? And we are safe. But what about arithmetic exception? If this occurred, will it be handled or not? It will not be handled. It will not be handled because you do not have arithmetic exception handling, and you also don't have the exception handling, right? Like this one, right? Right? You do not have it. Let me write the third variant, right? Which is this. In this case, what I'll do is I'll remove this malformed one and have the arithmetic exception. Now see this here. If you write this piece of code, right? Now what is happening here? The arithmetic exception can be handled, but the malformed exception cannot be handled. And it is why that's why it is giving an error, because it's a checked exception. Right? How to handle it? I have two options now. I can either add a catch block which can meet this thing, right? Which is this. Now you can see the error is gone. Or can someone tell me what I can write if I don't write it here? What can I write here to handle it?
To handle both, we can use exception parent class.
Right, exception, right? So you can see if I type exception here, right? Even if you're if this time malformed exception occurred, let's say this type of exception occurred, first of all it will check this catch block. Is it capable to handle malformed exception? No, it is not capable. So this piece of thing will not run. It will go and check this. It will see, can this catch block is capable of handling malformed URL? It will see, okay, it is not matching to it, but from the hierarchy, Java knows that exception is the parent of malform. So as per the rules of Java, this is capable of handling it. So it will go inside this and run this piece of code. Okay. Now the fourth part, and now what is happening here is exception is also a parent of arithmetic exception. So you can even remove this also, right? And still your code will work fine. If the error on malform comes, it will go inside this. If the error occurs on arithmetic, this will run, and this will also run, right? So we understand this point till now, right? What I'm only saying here is that if you tend to use, let's say, all three, right? Malform, right? And the arithmetic exception. which is E2 here, right? Arithmetic exception handling, right? If you do this, right, it is complaining. Why it is complaining? It is complaining because your catch blocks, right? First of all, there are multiple catch blocks, and the way catch blocks works, it starts from the first catch blocks. It will check here, it will see here, it will see, can this catch block can handle this type of exception or this type of exception or not. Let's say if any of these occurred, I told you exception class is the parent of all the exceptions in Java, right? So keeping that rule in mind, if the malformed exception occurred, you know that this catch block can handle it. So Java will go inside this and run the piece of code, right? Does everyone agree? Right? If the malformed exception occurred, this piece of line will run. Line number 40 will get executed, right? Right or wrong?
Yes.
Yes.
Yes, right. And let's say this time the other type of exception occurred, which is arithmetic exception. Then also this piece of line will run, right? Again, this will run. So try to understand, if any day, any time these types of exceptions are occurring, every time what is running? Only this catch block is running. These catch blocks are not getting a chance to run, right? These catch blocks are not getting the chance to run. Why? Because if you have multiple catch blocks, only one catch block will run. And if one of them ran, right, the rest will be skipped. And here, right, the way you have ordered them, right, what you have done is you have mentioned the parent thing first, right, which Java knows can handle everything. So these catch blocks will never get the chance to run. So what Java says is that please maintain the order. You should not write in an order of the more generic ones at the top and the more specific ones in the below. You should not follow that approach. What you should do is you should do the opposite of it. What you can do is you should write the specific catch blocks near to the try block, right? So what I will do is, and the ones which are more generic, you should place in the end. Why is that? See here, right? Now the error is gone, because now the as per the orders of Selenium Java, right? This is okay. You can see now, right? If the malformed exception will occur, right? First of all, this catch block will be tested, and you can see it matches to it, right? It's a specific one. So every time this piece of block will run, okay? If the malformed exception will occurs, right? So the other two catch blocks will be skipped. Let's say the next time arithmetic exception occurs, what will run? It will first check the catch, this catch block. This does not meet, so this will not be running. If you go to the next catch block, it will see, oh, this is a arithmetic one, and this is a very specific one. Let me run this. So it will run this block, and this time what will be skipped? This will be skipped, right? So, but let's say that a file system exception occurred. Let's say that file system exception occurred, and you have not added a catch block for it. So what will happen? This piece of block will not run, because these are not meant for file handling, right? This is for URL handling. So this piece will not run. Or because it's an arithmetic exception, not about file handling, right? So what will run? This piece of sketch block will run. So in this order, right, if you write this, there is a chance that all of your catch blocks can get a chance to run. Okay. If a specific exception occurred, they will be met with the specific catch block. And if there is something which is not meeting of any of these, you also have a generic one. So all of them will fall inside this, and the exception will be handled. So in a way, you are safe now. Okay. So the rule in Java is, what you should do is, if you're trying to handle an exception, right, trying to handle the exception, first of all, identify your exceptions, your different types of exceptions, and then start writing the most specific ones on the top. Okay. And then keep writing the more broader ones down. Okay. So it should be like grandchild on the top, then child, and then the parent, right? The reverse order of it. So if an exception of a specific exception occurs, the grandchild which is meant for that exception can catch it and can provide the logic inside this. Okay. So what we learned, you can handle your exceptions using a try catch block. right? And inside the what you should keep inside the try block, you should keep any of your code which can result into an exception. Okay, so you should place all your code inside the try block. If you need, if let's say the exception occurred, right? Now you need to handle that kind of exception. What you need to have is you need to have a catch block. So you will have a catch block where you can specify, you can have multiple catch blocks, and for each catch block you will have to specify what kind of exception that catch block will handle, and you will provide the logic inside this. And if you have multiple catch blocks, only one of them will run and the rest will be skipped if one gets a chance to execute. Okay, and the last rule is that you should obey the specific order, right? Where the most specific ones comes to the near to the try block, and then more generic one, and then the most generic one in the end. Okay, this way everyone will get a chance to run. If I was doing this thing, right, if I was doing something like this, you can see what kind of error this was throwing. Exception has already been caught. You see this? If I hover over this malformed exception here, right, it is saying that exception java.net malformed URL exception has already been caught. So you're trying to write a redundant code, right? That's why compiler is complaining. But you can see you have not written a line like this above. But why it is still saying? Because you have a parent above this which can handle this exception also. So compiler knows that this line of code is like a redundant code because this will never get a chance to run. Okay, so that's why it is complaining. So that's why it is very important to maintain the order of it and then write your catch blocks. Okay, so what we learn today? We learned about, first of all we learned about the handling part, right? We have only covered the handling part. We covered the try and the catch and the multiple catch blocks, the single catch, right, and the multiple catch blocks. And we talked about checked and unchecked exceptions. Okay, we have not talked about stack trace and the throws. And finally, let's talk about this also. I don't want to hold on to that discussion for another day. Let's do this. So you can have a hierarchy like this. We saw, right? You can have a try block, right? Okay, one more thing. Let's remove everything else. Let's remove everything from here to here. Let's remove this. If you would see this, right, you cannot have a try block as is, right? It's not that you can just write a try block. Okay, let me just comment this line also. Let's say you can see, right, you cannot simply have a try block. If you have written a try block, then you need to have some handling around it. Okay, because try block is just a guarded region which will look for your, if the exception occurs inside this guarded region, it will not throw an exception directly, right? It will try to see a matching catch block and then it will think about it, what to do, right? But here, try thing, right, cannot exist alone. So it requires either a catch block, which we just saw. So if I write catch block here, right, the error would be gone. If I write the catch block here, like this, right, exception A, right, the error is gone. Or what you can also do is you can have a finally block. Okay, you can have a finally block. In the end, run this. Okay, what is a finally block? As the name says, finally. Finally means in the last, right? Okay, so what here is, so you can see, right, either you can write a try catch or you can write a try finally, or you could also write try catch and finally. Let me write a catch block also. Exception E, E, and this block, right? You can see. So what variant you can write? A catch block here, let's say, a catch block here also, let's say. Let me write here. Malform exception. Let me write here exception E again, right? Here, right? So you can see You can see, right? I can have, I showed you, you cannot have a simply a try block. That is not allowed. If you are writing a try block, you either need to have a catch block with it. So the combination becomes like this. The combination becomes like this. Try catch, right? So this try does not exist. You cannot have it like way this way. But you can have a try block, then you can have a catch block also. A single catch block will also work. Or you can have a single try block and you can have multiple catch blocks, which we just saw. Or you can have a single try block and then you can have all the catch blocks, right? Whatever you want, one or many, and then in the end you can have a finally block. Or you can have a try block and a finally block where you will not have a catch block. Okay. Now, what is a finally block? A finally block is meant for the purpose, let's say you want it, let's say, see, the only purpose of finally block is that if the exception occurs or does not occur, you, let's say you want to run a piece of code, right? Let's say you want to run a piece of code irrespective of the fact whether the exception occurs or it does not occur, then this is your piece of block where you can write that logic. Okay, so what you should do is, let's say that you have a try block somewhere, right, where the exception occurred, and maybe let's say you did something like this. You said int uh, a equals to new int here, right? And you define the size of it, let's say, right? Now, when you do this, right, you have given us some memory space to this a variable, right? And now let's say the next line, maybe you did something like this: int c equals to a divided by 0, or not a, b divided, or 5 divided by 0, let's say, right? Here this piece of thing is running fine, but here as an exercise, because of this, you allocated some space in memory because of this line, right? And now your error occurred here, right? Right? And maybe if the error occurred here, right, let's say you can have a catch block to handle it, but let's say you, let's say that that catch block did not run because of some reason, right? What will happen, what you can do is, just to make sure that your code is logically completed, right, what you can do is you can have a finally block, right? And here maybe what you can do is, let's say you can write, the purpose of having finally block is that you want to do something, you want to do some of your, let's say, finished I mean some of your finishing task. So one of your finishing task here is that whatever memory you would have initialized to this a variable, right, you want to deinitialize it, so you will mark this variable as null, right? Let's say you want to do it, and you want to do it whether the exception occurs or it does not occur, right? So finally block is meant to always run. Okay, so this will always run, it will always run irrespective whether the exception occurred or not occurred. It will run in both the cases. Okay, right? So if the exception would have occurred, first of all, the control will move from try to where, to the catch block. And if it is able to find the a good catch block which can handle it, it will run that, right? And once it is done with it, it will go to the finally block, and whatever piece of code I would have written here, that will get executed. Okay, and what will happen next is, in case of the other part, let's say the exception did not occur, so try block is anyhow running, and then the finally block will run. Let me show you. Okay, I think enough of this discussion, let me just show you. I did not show you, right? Okay, let me show you this. And to show you this, let me just use this runtime exceptions. Okay, what I'll do is, I'll have this runtime exceptions in c equals to 5 to the right, and I will have a catch block which will have a runtime exception, let's say e, and I will write here s out handled by runtime. Okay, handled by runtime. Let me also have a catch block which will be specifically for the arithmetic exception. Arithmetic exception handled by arithmetic exception. And let me have the finally block. Finally block. and here I will write final block. Let's see. Let's run this code. Get student count, and here you can see the exception will occur. And let me also write one more line here. S out line after exception occurred. Okay. Now let's see if I run my code now, right? What would be the output which I should see? Okay. And this piece of code get student count is invoked from where? From here, right? From here. And what I will do here is, let me just do one more thing. Let me just remove it from here, and I will say int c equals to 0 first of all. Okay. And then if the exception handling is done, I will set the value as 10. Okay. If the runtime exception has occurred, then I will set the value as 20. If the finally block has run, I will run it with the value as 30. Okay. And then this is here. The try block will run and this will run. Okay, let me not do this. Let me just say int frequency. Okay. Let's run this. Let's see what is the output we'll get. Let's run this. Does anyone know like what kind of output I should see? I am trying to run this. Get student count. I am providing 0 here. It printed what? Okay. You saw the output, but okay, fine. But see, right? Let's try to understand this. First of all, last time when we ran that, it threw an exception of saying runtime exception occurred divide by 0, which did not occur this time. So it's a win, first of all. Now let's try to understand what really happened. When your program ran, right, JVM invoked your main method, and when you ran the main method, you can see we are invoking this method right from the classroom, which is get student count. Let's go there, and we are providing some input which is 0, which we are not anyhow using. So let's let it be there. We initialize the variable with 0, c equals to 0, and then the try block started. Here we are dividing a number by 5 by 0, and here, right, here the runtime exception will occur because we are trying to divide by 0, and it's a type of runtime exception, which is arithmetic exception. You can see, right, if this runs here, right, in the normal way, if the try block was not run, as soon as this line would have executed, the exception would have thrown in the on the output console, and the program would have stopped. But that has not happened. What has happened is, once the exception occurred, first of all, the control moved from the try block. So your try block, after this line, right, nothing has executed. You can see this has not been printed here, right? You can see this line has not been printed here. So whatever you may have after, once the exception occurs in the try block, right, it is not getting executed, first of all, right? So this piece of block resulted in an exception, and now your Java, right, will try to find a matching catch block. Let's see. You see here, it found the first catch block is about arithmetic exception, which is meeting to the exception which has been raised. And you can see it says handled by arithmetic exception being printed, and it runs that line handled by arithmetic exception. Does everyone getting this point? Right, just one.
Yes.
Right now, what happens next? Since this catch block ran, right, this catch block will never run, because out of your multiple catch blocks, how many catch block will run? At most only one. So it ran, so this will never run, right? So this is kept, and then it also so that, okay, I also have a finally block, and you can see, right, it went inside this and it ran this piece of code. It said final block, right, and then it set the value of c to be 30. In your arithmetic exception, what is the value of c you have set? 10, right? And here you're setting the value as 30, right? So what is the value you will return from here? 30, right? Not 10. because the finally block ran in the end, right? Right, everyone?
Yeah. Yes.
And since 30 was returned, it was sketched in the school block here, right? Over here in the count, right? Value became 30 because that is what it is catching. And then it printed this, so we're receiving a 30. Okay. Now let's do one thing. Let's not throw an exception this time. Let's not throw the exception this time. I will say C equals to 5 divided by 2. So this time it's not an exception. It will work very fine. And here, let's see what all we will see now. Can someone tell me what should be the output this time? If I run my piece of code now, let me remove this. Okay, let me do one thing. Let me take it from here only. This num I'm using, right? Let me put it num here, and I will control it from here. Let me provide 2, right? So Daga, you're saying something, then it's not audible.
Yeah, yeah. No. Line
Okay.
after the exception occurred and 30 will be the assigned to C.
Okay, and this piece of line will also run, right?
Yes.
Okay. So in that way, right? What is happening? In that way, what Sudhakar mentioned, what is happening is line after this one run first, right? And since the no exception occurred here, right? So there is no need to run any of your catch blocks, but still the finally block will run because that is the purpose of having a finally block. You want to have a finally block whether your exception occurs or it does not occur. So what will be the output this time? The output would be line after exception occurred. Then it will directly go from the try block to this finally block. It will run this line. It will also run this line. And once it returns the value, what is the value return? 30. Okay. Let's run this now. You can see, right? Line after execution occurred, which is this line. So it means that there was no exception this time. Okay. So it was able to run this line, and there was no, since no exception occurred, so there was no need to run the catch blocks. So none of the catch blocks ran, and then the finally block ran. Okay. One last thing about this part. Let's say I was currently generating what? Arithmetic exception. Let's say I will not generate this. What I will generate is, I will generate another type of student s equals to this. Okay. Now you can see I am trying to access a student, right, from the array which does not exist. So 6, I'm trying to access the 6th index which does not exist in that array, right? So what kind of exception it should throw? Fizula?
Array index out of
Array index is out of bound.
Right? Array out of bound. Okay, out of bound exception, right? This is the type of exception to throw. Now, if it throws this exception, right, which catch block it should run?
The runtime.
yeah runtime.
Runtime, right? It will go in the runtime. It will not run this because this is a specific one and does not fall inside this. Great. But here it has a parent which can handle the which has a child of this type, right? So Java will run this piece of code, and then this piece of code will run the finally block. Okay. Let's run this. Right? What is happening this time? The error occurred here, the exception occurred here, so this line never ran. As soon as the exception occurred, it tried to find the catch block. This did not meet, so this did not run. Here, this was the one which was not the exact match, but it's a parent of it. So it got the chance to run, and it printed this line, handled by runtime. And once the catch block ran, so even if there were more catch blocks after this, they would be skipped. And in the end, the final block will run, which is this part, final block. Okay. One last thing for today, or the second last thing for today is, I will show you if the exception occurs, right? You can see, right, over here I am not telling about that exception which has occurred. Okay, but let's say I want to also print that exception, right? I also want to print the details. How can I do it? What you can do is there is a very specific thing. You can see, right? You created, this is what you're trying to create a variable. It's like a local variable here, right? It's like a local variable which you created for this type of class. Arithmetic exception is a class, right? Like in your methods, right? What you do something like this, right? You provide the variable name, which is could be a primitive type or a string type, which is a class, right? Similarly, this is the variable name, and this is the data type, and this is the variable name. So you can access it, right? What you can do is, let's say in this case itself, I will say s out e dot. You get access to all the methods which exist in which class? In the runtime exception class. It's a class, right? A class can have methods and variables and everything, right? So does these classes. Runtime exception has these methods. Not only runtime, every other exception class, right? Any other class, right, will have those methods. So the methods which is most commonly used to print about the exception details is what? Get, stack, trace. Okay. If I run this with this logic now, let's see what will you see. Okay. Let's run this now. I did not print this. Just a second. Oh, I'm doing it incorrectly. You do not have to do it inside system.out.println. It itself is enough to print it, because inside this the logic is written to print it. Okay, so let's try to run this again. Okay, what am I doing? Just a second. E dot
Till
get
it print stack
Print
trace.
factory.
Sorry, can you please repeat? E dot
Factory.
Print stack trace.
print stack trace. Oh, I was using get stack trace. Okay. Sorry. Yes. So now we do not need to write in the s out thing, right? It will print that way only. So if I run this, you can see this, right? This piece of thing you were already getting when you were not handling it, right? So it was throwing this kind of an exception, right, in that point of time. But here, right, you are handling it, and let's say you want to also show it to the user that while running your program, it did encountered this kind of exception, and you're telling it to the user that okay, this is something which we noticed. You could use this information maybe to log this into your logging framework, which can only show your error logs, right? And that is what usually people do, right? So you can use this print stack trace method to get all the information about your error, and it shows you, right, where the error occurred. You can see here, right? So okay, this is what. Okay, what is a stack trace? What is a stack trace is the last part of our discussion today. Okay, I promise that's the last part. So the last part is, if you would clearly look at our code, right? How does our code look like? We had a student, we have a school class where we had the main method, right? And here we were invoking a method of get student count from a class called as classrooms, right? Classroom. Let's say these are the only classes we have, and there was a method get student count here, get student count here, right? And here there was a line of code which was resulting into an error, and we were calling get student count from this class, right? So let me just cover this boundaries, right? And this is a classroom where we have this method. So int, that will here we have the try, catch, block, whatever that is, right? Now we already talked about the stack, the call stack and the memory thing, right? The heap memory and the call stack and everything we have already discussed. But let's try to understand here it again. In the call stack, right? What happens? This is your call stack. What happens there is JVM when it starts to run your program, right? It looks for this main method. So it will add this main method into your stack here, right? So it adds main here, right? So that it can be invoked. Once it starts invoking it, right, it reads this line, right? And here, let's say it found this method. As soon as it found this method, it will add this here, right? We learned this, right? That all your method names goes where? In your stack. So get student count will be placed inside your stack here. Okay. Now, if something else was there, right, inside the get student count, it was invoking some other method, then that method would have been added on top of this stack. Okay. Now, how it is removed from the call stack? How it is removed? It is removed in a way if your get student count method was completed successfully. Only then this thing would get removed from the call stack, right? Right. And once the main method gets completely, then this part will also remove, and then you will have a call stack which would be empty again, right? But in this case, let's say the exception occurred, right? The exception occurred here, and you can see your main method is not completed. You have another line here, s out, let's say count. You wanted to print something, but you are still running this line, and because of this line, the control moved from this line to this code here, right? And here also, let's say there was another line s out, right? And it did not complete it. And let's say the exception occurred here. So what is happening? Your call stack still has these methods there, right? And it is not emptied because they have not completed yet, and the exception occurred. As soon as the exception occurred, right? What will happen is the exception occurred here. So this is your origin place. This is where your exception occurred, right? Now your Java, because of this call stack, right, you will get to know, okay, where did the error occur? It occurred in get student count, okay, at which line? Line number 10. Okay, okay. And from this, looking at this call stack, right, it knows that who made the invocation to this method. Main method made the invocation to this method, right? And here it knows which line of code pointed to this method here, right? So there is a, let's say, line number 6 here. Line number 6, right? Now what Java will do is Java will use this information to print on the console when your exception occurs, and this is called as stack trace. Okay, it is a trace of your call stack. Okay, where it just publishes what information it sees in the stack at the time when the exception occurred. Now see this. If you would look at it, right, when you are reading a call stack, right, sorry, a stack trace, what you should do is you should read the first line to get to know about the kind of exception your code is throwing. So you get to know, okay, array index out of bound exception occurred. So it will click here, okay, it is related to something related to arrays, and maybe I'm trying to access index position which I should not access or which does not exist. So we got that point. Here it also telling you which index position you're trying to access here. 6th position, whereas the size is only 5. So 6th position is anyhow not allowed, right? So okay, but if you read only this line, you don't know. Let's say you have hundreds of classes and thousands of lines of code. You will not get to know where did that error really occurred. So what Java is doing for you is Java is printing all that information. And how it is printing? It is printing based on that call stack. You can see, right, it first printed the first value which is on top of your call stack, which is get student count, and it's telling you it is this is a method which is invoked, and this is invoked from which class? Classroom. So you can go inside the classroom, and which line occurred, which is the line which occurred this where the error occurred? Line number 19, right? So you can read this, and who invoked, and how did you reach there? How did you reach there? You reached it from this line, school.main, and from line number 6. Okay, so this is a stack trace which gives you all the information which you need about the exception, the where the exactly the error is, and how did you reach there, right? If there are 10 classes, right, let's say there were 10 different method invocations, right? So it will show you complete stack trace of all the 10 methods which originated from where and from where, right? And that's why sometimes you see a long text stack trace being printed on your console when such an exception is thrown, right, or it is not handled. You see all of that information, and this is called it as stack trace. Okay, okay, great. So what did we all discuss today? Let me go back. So we discussed about try, and finally we discussed about exception propagation, which is stack trace. We discussed about checked and unchecked exceptions, right? Only part which is pending is the declare thing, right? Throws method. Now, let's say that we do not want, we want to be very smart, and we do not want to handle anything. We say my manager asked me to just write the logic. He did not told me to handle the exceptions, right? Because if I have to handle the exception, I would have to write some extra logic. Let's say I'm not in the mood, I don't want to do it. What I will do is I will not handle it. But if it's a checked exception, my compiler will not allow me to save my work because it will keep throwing the error. And if it's an unchecked exception, then it is morally not correct for me to leave it as is, right? So what should I do is I should use throws keyword. So let me just show the last part. What you will do is, let's say I don't want to handle any of this. Okay, let's say I don't want to handle any of this. So let me remove all this. Let me remove all this. I will not have, okay, let me just do one more thing. Let me not remove this so that you can refer it back. You create another method. You create another method. And in this method, what I'll do is I will not add my, okay, let me say student count 2. And here, right, I will not have a try catch block. I will not handle it. I will not do anything about it. If the error occurs, let it occur. I don't care as a developer. So what I can do here, see, your runtime exception is not a checked exception, right? So compiler will not complain. If you write it this way also, right, it will still compile and your code can run, but it will fail at runtime if such an exception occurs, which we know. Now, what you can do just to morally support, right? So that you can allow, see, what you should do here in this case is for the unchecked exceptions. What you can do is you don't want to handle it, great, don't handle. But just do one thing, just declare that what kind of exception your method can throw if someone uses it. So you can just say that's it, and your job is done. Now you are leaving out your responsibility. You're saying, okay, it's not my responsibility, I will not handle it. But now whose responsibility it will become? It will become the responsibility of someone who would invoke this method. Okay, who would invoke this method. But again, you have to remember the rule is for checked exceptions only. Arithmetic exception is a unchecked exception. Okay, so let me show you. Let me first show you for the unchecked. What is unchecked? Malformed exception. Malformed URL exception is a checked exception, right? It's a checked exception. Checked exception. Right? So this is the part. And let me try to invoke this method from the school class, right? From here. See this. If I say cr dot into and I try to provide a value as 6, you see here it is complaining. Last time, if I would have, if I was doing something like this, you can see if I was doing something like this, it was not complaining earlier, but here it is complaining. Why it is complaining? Because of that throws keyword. What is happening because of it? Now, because of that throws keyword, your Java is getting to know, okay, my method which I'm trying to invoke can throw an exception. And how does it know it? Because we have mentioned a throws keyword. We have mentioned a throws keyword here, right? We have mentioned a throws keyword, right? And because of this, our compiler gets to know, okay, this method here can throw that exception. So it is saying, okay, since that can throw an exception, and since that class has not handled it, now this is your responsibility to handle it. Okay, now either you can place this piece of thing right inside the try block here, like this, right? And then add the catch block, whatever you want. Right, exception E, right? And you can see the error is gone. So now this part of handling the exception was originally the duty of this method, but it avoided it. It said, no, I will not do it. I'm not in a mood. So what is happening is but it let others know that, okay, if you try to use my code, it can result into an exception, and I'm letting you know as a warning, right? And since compiler came to know about it, compiler said, okay, then whoever wants to invoke this, please add the necessary handling, right? Or even that person can throw it to someone else. So now, so this method over here, right, has an option to do this. Or what this can also do is, it can also not handle it, right, and pass it to someone else. So it will also say throws malformed exception. So this is another developer, good developer, which does not want to take the responsibility of someone else, right? Malformed exception, URL exception, right? This is the one, right? You can see the error is gone. Everything is sorted. No one is handling it. So everyone is letting others is passing on the ball, right? So student count, so classroom class said it, okay. That method said it, okay, I will not handle it. Let others handle it. Okay. So when main method was invoking it, then it also said, okay, it does not seem to be my responsibility. I don't care. Let me pass it to someone who makes invocation to my method, right? And now it is like the root of everything, right? The main method. JVM invokes this method only, right? So what will happen here? These exception will be thrown, and JVM would be asked to intervene, right? And if the error is thrown, right, what will happen? The exception will be generated, and the program will stop. Okay, right? So the correct order is either you handle it properly, or you can throw it to the upper layer, right? Whoever is making an invocation for you. And right, and if no one, and let's say that main method decided to handle it, then things are sorted here itself, right? So it can end up, it can have a try catch block, and the things are sorted at this level itself. But let's say even this did not do the things, and it just added the throws keyword. So you can see, right, no one is handling it, everyone is throwing to someone else.
Can you
So
just
in the,
run this?
I can run this one, but here I have to do some wrong thing, right, around the URL there. So which I don't want to do. Let me do
What
for
is the
the,
final thing? Like, who is going to handle it? Since the main, right?
no one will handle it. Let me show
And
you.
everything will run successfully.
It will not run successfully. Let me show you. Arithmetic 0 exception, right? Let me divide it by 0, right? Let me just print a line here so that we know that this line did not run, right? Line number 12 ran, let's say, right? So I'm saying throws not malformed, have to run throws arithmetic exception, right?
Can we throw arithmetic expression?
Sorry?
Can only the checked ones can be thrown, right?
No, you can throw anything, checked or unchecked also. So there is no control on that. You can throw any of this. If you are aware, like your method can throw checked, mention checked. If you know that your method can throw unchecked, mention that also. And in this case, right, we are throwing an unchecked one, which is arithmetic exception, right? Right, Vizela?
Yes, yes, got it.
Okay, so let me run this. And your question is, what will happen in this case? What I'm saying is, let me write the line. Let's see the output here, right? Let us see. Let me run this. Now you explain me what really happened. You can see the error
Got
here,
it. Main thread. Yes, yes, main thread got it. Okay, fine.
right? See here, right? Now let me explain, right? See here, everyone. What happened here? Your main method is the one which is invoked by JVM, right? So that it started running. It ran this line, it created the instance of the classroom. Great. It then started running line number 10, which is invoking this method, get student count to. As soon as it tried to run it, we provided a value 0, and the control from line number 10 moved to this class, and the line number 46 is running. At line number 50, right, we are doing an operation of c equals to 5 divided by num. What is num? 0. So 5 divided by 0 will result into an arithmetic exception, right? And here at this line itself, line number 50, the exception generated. As the exception generated, you are not handling it. There is no try catch block there. But what do we have? The throws keyword. So as soon as the line number 50 generated an exception, none of this ran, right? None of this code would have ran, first of all. And it sees this signature. It shows throws arithmetic exception. So what will happen in this case? This arithmetic exception, right, would be thrown to the someone who started this invocation, okay, which is this. And you can see here, right, even this thing over here is not handling it, and it is throwing it. So the exception after this line is thrown above, right? So now this line did not run, an exception just halted our program here itself, right? And now, since this arithmetic exception is thrown on the main method, now who invoked the main method? JVM. So now, since JVM received this exception, now JVM does not know what to do about it. The only thing it knows is stop the program. It stopped the program and it printed the stack trace. And it said that your program is having this issue, right? Divide by 0. And it is telling you again, based on the stack trace, right? How things were happening. Okay. What you could have done here is, let's not use this. If you do not want to have this kind of behavior, you can have try block here and the catch block here. Let's say exception. I will say just exception here. You can write the specific ones. I will write exception occurred. Okay. Let's say, right? Let's run this now. Let's see the behavior this time. You see, it's time your get student count to method did not accept it, they did not resolve this or handle this, but who handled this? This main method, because there is a try catch block, and you can see the exception the exception occurred here. The control went back to this line, and here it found that okay, this piece of thing is under try block, so it tried to run the catch block, so it ran this line, and then the program did not stop, it just continued normally, and the next line also ran. Okay. Okay, so this is the entire thing about the exception handling. You can handle your exceptions. First of all, you have to understand what is exception. Exception is anything which can halt or alter your program flow, right? Your execution flow. How to, what to understand exception, you have to understand that there is a certain hierarchy in Java, which is that there is a object class. Within the object class, you have throwable class. Within throwable class, you have error and exception. And within exception, you have runtime exception and the other exceptions. And if you would remember the chart which I showed you, all the part of errors plus this runtime exception is called as unchecked exceptions, and other exceptions are called as checked exceptions. Now the rule in Java is all the checked exceptions can be identified by the compiler. So if you have a logic which can result into a checked exception, the compiler will detect it and it will stop you from running the code until you handle it or you declare it by using the throws keyword. Okay, and for unchecked exceptions, compiler will not complain. But if the exception occurs, your program will stop at the runtime, right? Now, how to handle things? You can use try catch block. A try is not an isolated thing. It can only work in combination with catch block or multiple catch blocks or with the finally block. What is finally block? Finally block is something which will always run whether the exception occurs or does not occur. And if you have multiple catch blocks, you should remember that only one catch block will run at a time and the others will be skipped. And you should respect the order of your catch blocks. The most specific one should be on the top, and more generic one should be on the bottom, right? And if you do not want to handle it, you just use throws keyword, and then the responsibility is moved to someone else, not to yourself. And if you want to print this stack trace, you can use the inside the catch block. You can just use the variable name of your exception dot print stack trace stack, right? Whatever that method is, right? And this is the entire thing which you have to understand if you want to handle a exception in Java. And that's it for today.
One last doubt, if you don't mind.
Yeah, please.
See, in the classroom of Java, right, line number 46, I can throw any number of exceptions, right, using the comma.
Line number 46. Yeah. What is the question?
after arithmetic, we use comma and throw any number of exceptions, right?
Yes, yes, yes. You can put as n number of exceptions. I can do something like this. You can write here malformed exception. I think it's a comma there, malformed exception, right? And whatever exceptions you think your method can, result into, right? You can add all those exceptions here.
Which is the best practice? Like using comma and throwing so many exceptions, or just a common exception, just single exception, or using so many exceptions and throwing commas?
I think it is. See, I would say it should be a common one there. It should be a common one, because if you would see the behavior of the compiler also, right? If you are throwing, okay, let me think about it. What I should say. I think the more specific ones are the great one, right? Because then you get to know that what specific type of exceptions your code can throw, right? So I would say specific ones, not the common one. Like similarly, like we were discussing about the catch block. So at least by reading this signature itself, the person will know, okay, what kind of exceptions this piece of thing can run. Otherwise, if I just say exception here, right? If I just say exception here, it will not give me much of the information. What to handle, right? I can write simply like this, right? How will I know like what kind of exception this piece of code can throw me? It can throw anything. It can throw array index out of bound. It can throw malform. It can throw file import out exception, right? Anything. How good? I mean, what value it is adding to someone who is making an invocation to this, right? You're understanding this point.
Yeah, Kill. In the framework side, for better code readability and maintainability, when we use like exception class, it will handle both like checked and unchecked. And also it will improve the performance of JVM, because it has to go and search each and every catch block if we have multiple. That's what I feel. But it's a different practice again. It depends on the requirements.
So you're saying we should use exception here in the throws keyword, or you're saying you should not use it?
Yeah, what I feel like using common generic exception, where we can avoid multiple lines of code, we can improve the JVM performance by avoiding searching multiple catches.
I don't think that way actually. I think that is the exact opposite which you're saying, right? If you specify exception there, right, then try to understand there is lot more processing which is required to be done here, right? Because here now you have put it into a bigger basket where there was a sub basket inside that bigger basket, right? Where you could have easily fit in the things. But now, because you said you gave the bigger basket, right? Now you left the job to the JVM to do more things, right? Whereas you could have handled it by yourself. So what I would say, but I would again say,
it's like, okay, what if we have a new exception introduced in the code by adding new feature? Again, we need to go and add that catch block to handle.
That is what you should do. That is what you should do, and that is what people should do in their code. It should not be like a common thing that you just start adding. Otherwise, what we will do, we will just have one catch block and we will have exception only inside this, and anything occurs in our code, it will be handled there. Try to understand from that perspective, right? If you are throwing an arithmetic exception, right? Arithmetic exception as a class has some methods which can help you to resolve your arithmetic operation issues, which you will not find in a class of malformed URL exception class, right?
Yes.
So how will you get that benefit? You will not get that benefit using the exception. Otherwise, you will be involved in doing upcasting and downcasting around everything, right? Why to get into that complex thing, right? Make it simple. Just use the specific catch blocks which can meet your needs, and then you are okay with it. Even if you tomorrow someone writes a code which results into an exception which is not handled, right? See, as a ground rule, try to lay down this formation. Have specific ones on the top, and always in the end have an exception block. Okay, have the exception block, and then mention there, but still print your stack trace so that you can know what kind of exception was generated when the program ran last time, right?
Yes.
So if someone can read the logs and get to know, okay, this is a new exception which I'm not handling, so why not add a new catch block there above that exception thing, right? So that you can handle it properly, and then you can provide the logic around it, right? And if tomorrow something else occurs, then again you will use the same process, right?
Yes, yes, okay. Yeah, one last clarification, Akhil. In the previous program where we have multiple catch blocks, right? There we are trying to handle all the unchecked exceptions alone. Unless we have exception class, it won't be handling any checked exceptions, right? I just
Right,
need
right, 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 right. You're absolutely
yes,
right.
yeah,
What
that's
will
right.
happen? What will happen in that case if, let's say, you are only handling unchecked, or let's say some specific exceptions, and you do not have that exception class, right? The main class there, you do not have it there. And if a exception of if a exception occurred which you are not handling, right, and it occurred, what will happen? It is as good as you're not having a try catch block, right? What will happen is your program will stop because there is no handling for that exception, right?
Yes, 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 okay, yeah.
Okay, great.
That's it. Yeah, thank you, Akhil.
Yeah, no worries, no worries. See, again, exceptional handling is a very I mean, I will not say it's an easy topic, right, for people who are starting new. But if you would see, right, if you remember all the rules around it, right, you will realize that everything can put in, and you can still handle around this, right? But the important part is that the rules should be very clear, which I'm trying to lay down here. Okay, we will see all of this in action when we talk about creating the frameworks, right? Because that is our core area where we will get into and try to see all of this. But for the meantime, right, I would advise everyone, please go back and practice whatever I showed you, right? Try to play with whatever you know about in Java. Let's say, try to create some exceptions of check type, unchecked type, right? And try to throw them, try to handle them, and all of that, and play around it. You will get to know more about this, right? And this is the way we should all learn if you want to get more about each and every permutation combination, because this is the way which I learn. So I think it was a good session, right? I know that it got almost like 3 hours now, but I'm okay with it, right? Since we
Just
covered
one more thing
everything.
from my end, last part.
Yeah, 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 please,
Are
please
we
go.
going to do the custom hand exceptions later in the design pattern part, or
Okay, actually, I did not intend to cover it because I don't
yeah.
think like we want to have that kind of thing in our framework somewhere. At least I do not have it in my head. But if you think a use case is there for it, let me know. I
No,
can.
actually, I don't have any practical knowledge about Java. Like for my interest, I learned it. So at that time I
Okay,
learned it. So if there is no practical much knowledge of it, then I don't think so. But yeah.
okay, okay. See, again, I would say that let's keep it this way only. We will use only the exceptions or things, right, which we already have generated here, right? But we will think about it when we will start designing a framework. If there would be a need, I will explain it there. Okay. But as of now, let's keep it this way only, that we are just learning the parts which are coming from Java itself. But yes, your question is valid. We can generate our custom exceptions also, which is can be done in Java. But how to do it, why you will do it, we can talk about it maybe when the need arises.
Yeah, sure, sure. Thank you so much.
Okay, okay, no worries.
Yeah, this session also clarified like we can also use unchecked exceptions using throws keyword also, because like Fizla, I was also thinking like only checked exceptions can be used for throws keyword.
See, again, even you, not only you or Fizzler, right? It is even me, right, who gets confused around this, because I also don't remember everything, right? So I was, when I started, right, I think I read about checked and unchecked exceptions around 1 year back, and today, because I have to explain you, I I was thinking to get back and check my notes and get that clarity, which I didn't. So, but when I read that line on the net, right, then everything got flashed here. So everything got back, and then I realized, okay, this is how it works. So, but you're right, right? Everything you cannot remember, but if you have seen it once, right, then if you would, if you would experience it next time, you will get to know everything in your main memory there. So that is how it works. But it's good,
Yes.
right, that we covered all of this.
Yeah, yeah, thanks.
It brought some clarity. Okay, I think we're good for today. Sorry for the extended call today, but I think we are able to complete our exception handling, which was more important for all of us. Okay, thank you so much. If no other questions anyone has, right? Tomorrow we'll try to wind up all the remaining topics of basic Java, which I just mentioned. Like one was debugging part, and there are enum which we wanted to cover. There are some basic operations which are like arithmetic operations, the bitwise operations, the shortcut circuits, and all that. We will cover all of it tomorrow, and we will wind up basic Java. Tomorrow is the last day for basic Java, and then Thursday I'm planning to start the collection framework. Okay, so let's do it this way. Thank you so much for joining today. Good night. Let's meet tomorrow.
Thanks, Akhil.
Bye bye. Bye bye. Bye. Thank you. Take care.